inverse prime of 5, right? So let's think about this. I've got the inverse function, and then I've got the original function. Now, what I really want is to figure out the derivative of the inverse at 5. But I don't know what the inverse function is. I really don't even know what the original function is. So there's no way for you to be able to work and get this answer, right? What we want is f inverse prime at 5. That is what we desire for the final answer. But there's no way for you to work entirely on this side. I don't know what f inverse is, so I can't take its derivative. If you can't take the derivative, you can't plug in 5. There's no way. So what you're going to have to do is, instead of working on the side with the inverse, you're going to have to flip it over and work with the original function, because I've got some information about the original function. All right, first thing though is you need to figure out what is the correct x value for the original function, right? It's the first step in my process. Or if you think about the formula, that first step, right? Finding the x value for the original function, that is what this stuff right here, f inverse of a, that means find the correct x value for the original function, which here it's pretty obvious. If I plug in 3 to the original, get out 5, that means f inverse of 5 would be 3. So the inverse was working with 5. That means here my original function is working with 3. There's a relationship always between those two x values. You have the x value for the original, you have the x value for the inverse. They're related. If you were to plug this in to the original, you should get out 5. Or if you were to plug in 5 to the inverse, you should get out 3. But the first step in the process, we're doing this first thing in the formula, it's always going to be find the correct x value for the original function. Then I'm going to take and evaluate the derivative for this new number, which is really kind of nice. I don't have f, but I have f of 3 equals 5. That's really nice. It tells me 3. And it already gives me the derivative, right? F prime of 3, it told me, was 7/2. So the question already gave me everything I needed. Everything with the original function, and its derivative was working with 3's. Kind of a little bit strange that this is 5, but not really, because this inverse is using a different number. If the derivative of the original at 3 is 7/2, then this derivative for the inverse at 5 is going to be the reciprocal. Remember, go back to that previous question. There's always going to be a relationship between these two derivatives. Now, the original function gets plugged in with one x value. The inverse gets plugged in a different x value. There's a relationship between those two numbers, but there's the two parallel tracks with the two different numbers, but there's a relationship between those two derivative values, and that's just to take the reciprocal. If you can't work entirely on this side with the inverse, you have to flip it over, figure out what that correct x value is for the original, do all the work over here with the original function, and you get this value, and then to switch from this value back over to the one that you truly desire, you just have to take the reciprocal. So that's kind of what we're doing here on this process. Couldn't work with the inverse, so I flipped it over. I had to figure out what was the correct x for the original function. It kind of gives you, all the information is about x equals 3, so it kind of limits you, right? It's got to be 3. You already have the derivative. This would be like having the 12 from the previous example, but if the derivative for the original is 7/2, that means the derivative for the inverse, remember it's a different x value, but that's fine. The derivative for the inverse is going to be 2/7, right? If you really understand this weird inverse rule, this is a 5-second question. You see this, and you're like, okay, reciprocal, done. A little bit strange, but that's the process. Find the x value for the original function. That's what this stuff is telling you. Then you take and you evaluate the derivative at that number. That's why you have f prime of that stuff, and then reciprocal is 1/. So all of this is the formula. This stuff right here is the first step. F prime of that stuff, that's the second step. 1/, all of that answer, that's the third step. The formula is just easier to remember than that weird, ugly formula. All right, let's do the next one. So here we go. Sometimes we're not given all this information about f prime and or f inverse and f prime. Sometimes we just have the formula. So let's go for it. Remember, I have the inverse function. I have the original function. Oops, not f prime. Looks like the goal for this is to find the derivative of the inverse at 2. Right? So the x value for the inverse is 2. And that's the goal, right? I want to find the inverse. Then I want to take the derivative, plug in 2. And this right here is what we're trying to find. Now, it may be possible, here I'm given the original function, it may be possible to find the inverse. It may not be possible. Here, let's think about it. If I algebraically were to try to find this inverse, remember I would switch the x's and the y's, so I'd have x is equal to y cubed plus 2y minus 1. If I could somehow solve that for y, well, this would be the inverse function. But this is cubic, and you're not going to be able to solve that algebraically and get y equals by itself. It's not possible. If I could, then I could just take this inverse. I could manually take the derivative myself, and then I could plug in 2. The problem is this is not something that we can do. So I can't work on this inverse side. I'm going to have to flip it over and work with the original function instead. That's okay, but the first thing I need to do is figure out what's that correct corresponding value for the original function. The value for the inverse is 2. The first thing that you need to do is the f prime or f inverse of a, or finding the x value for f. First thing you need to do is figure out what is the correct x value for the original function. So think of something like this. F of what is going to give you out 2? All right, you need to figure out what is this x value for the original that's going to spit you out 2, because that's the x value for the inverse. Now, if you have a calculator, you could just set that thing equal to 2, right? You could do f of x plus 2x minus 1. You're just setting that thing equal to 2. If you have a calculator, you could solve it. If you don't have a calculator, you could try to solve it by hand. Here again, since this is cubic, it's a little bit tricky to do by hand. Let's just try to guess and check, right? Sometimes it may not be super easy to do. If it's not, you can probably just guess and check, and it's usually going to be something like 0 or 1 or negative 1. So let's just try 0, because that's the easiest thing. If I were to try x is 0, let's see, 0 cubed plus 2 times 0 minus 1. So I have 0 plus 0 minus 1. So if x equals 0, you're not going to get out 2. So 0 is not the correct answer, right? So I tried to guess and check, tried 0, didn't work. Let's try the next one. Let's try 1. That's kind of the next nicest number. If I were to plug in 1, let's see, 1 cubed would be 1. 2 times 1 would be 2. Let's see, if I had 1 plus 2 minus 1, does that end up giving me out 2? Oh, yeah, look at that. So f of 1 equals 2. That means this value, right, the corresponding x value that you need for the original function, it's 1. The x value for the inverse was 2. It gave you that number, right? This number is the value for the inverse. But the first thing you have to do for this weird little process is figure out the correct x value for the original. And that's like 90% of the work. Everything after that's downhill and it's pretty easy. First thing you got to do though is find the x value for the original function. That's like doing this step in the formula. I'd like to do the process though. Find the correct x value. If you have a calculator, graph them, find the intersection point. If not, guess and check. Usually it's going to be something like 0, 1, or negative 1. Really easy. But once I know this value for the original, can take and evaluate the derivative. This is a super easy derivative to take. Once I take that derivative, plugging in 1 is going to be really easy, and then taking the reciprocal really easy. So once I know this number, just really quick route to the answer. Let's go for it. So this derivative function would be 3x squared plus 2, super simple, plugging in. Now, do not plug in 2. 2 is the x value for the inverse side. You had to figure out what the correct x value was for the original function, right? If you were to plug in 2, you're going to get it wrong. Don't do it. You have to plug in this new correct value, which we found was 1, right? So 1 squared plus 2 looks like if you were to take and evaluate that original function at 1, it looks like you're going to end up getting out 5. So the derivative of the original at 1 is equal to 5. That means the derivative of the inverse at 2, it's not going to be 5. It's going to be the reciprocal. It would be 1/5. So it's a little bit strange, but this process is just 3 steps. First thing, you have this original function, or you have this inverse and its derivative, right? It tells you right in the middle, right in the beginning, that the inverse is using 2. You have to figure out what is the correct x value for the original. And that one, it was a little bit tricky because you had to guess and check, but we figured out, hey, if I plug in 1, I get out 2. So I know the x value for the original function is 1. Once I know that, really easy. Take the derivative, evaluate the derivative, take the reciprocal. Pretty quick, pretty simple. The weirdest step is this first one, finding the correct x value. But the more you do it, the better you'll get. All right, third one. Let's go for it.